Welcome to Operations and Supply Chain University. I'm Jerry Wright. This is lesson number 19, Time Series and Control Charts. So variation tracking, why would you want to do a time series or a control chart? Well, we want to look at variation. So variation tracking is a common way to both analyze and control parameters that change over time. Charting the data over time gives us the needed information to look at what we need to potentially change or adjust or work on reducing. Now, in any given system, there are two types of variation. There's common cause variation. This is variation that is inherent to the system. It can only be addressed by changing the system itself. It occurs all the time. It's normal and inherent. It falls typically within the lower control limit and the upper control limit 99.73% of the time. So this is very normal variation between your upper and lower control limits. Now, there's also typically special cause variation. It's due to assignable causes, like an operator hits the switch wrong, or a machine breaks down, or we have defective material. Those are all assignable causes. Through investigation, we can often determine these special causes and prevent their reoccurrence, thereby reducing variation. Keep in mind, special cause variation falls outside the lower control limit and the upper control limit, and it's usually temporary in nature. It's not lasting. Okay, so variation in series time plots. To address variation, we may choose from a few different approaches. There's a time series plot, or I like to call those run charts. There's no upper and lower control limit. There's no center line. We just plot the data over time in order that they occur. Then there's control charts. The data is plotted over time, but we have an upper and lower control limit at the mean plus 3 times the standard deviation and the mean minus 3 times the standard deviation, or 3 sigma. And the center line is the mean or the average. Capability analysis, again, refer to Ops University, Lean Six Sigma Green Belt lesson number 15 to learn more about capability analysis. It's another thing you can do to address variation. Great tool. Let's review the primary time series plots that can be used in studying variation, both run charts and control charts. There's an example of a run chart. We'll look in more detail in a second. And here's an example of control chart. You can see the upper and lower limits. So in a time series plot, it's basically just over time. This happens to be the daily high temperature in San Diego, California, where I live. And you can see the dates on here and the temperatures, and then the median temperatures in the center. You don't have to put the median, you can. It just means the middle. Again, you can see the temperature, and it's just plotted over time. So that'd be an example of a simple run chart that can be done in Excel. Now, in your Lean Six Sigma Green Belt Toolkit from Ops University, you have an example of, it happens to be platinum temperature in degrees centigrade or degrees Celsius. So you can see here there's 20 readings, the temperature's there, and there's actually a trend line that's on this as well. You can click on the data series and add a trend line easily in Excel, and you can see the platinum temperature is gradually increasing from just under 202 to probably about 202.3 or 4. Again, a platinum temperature and a run chart, very easy to see how to create this. You just highlight the platinum temperatures and hit insert chart, and boom, there you go. You've got a nice run chart. These are easy to update, easy to create. And again, there's an example for you to look at in Excel. Now, a time series plot, a typical one that we would use would be a control chart. Now, for control charts to be worthwhile, the process examined should be in control, meaning that it's reasonably stable and it's not riddled with special cause variation, which are those points of data that are outside the lower control limit or upper control limit. Now, control chart data requirements, you need a minimum of 25 consecutive subgroups, so meaning little groupings or gathering of data, or minimum 100 consecutive observations. That's because you need to build the control limits with some meaningful data, and 100 is usually a good number. These could be samples taken every hour, samples taken every shift or whatever, but you're going to have to get to a lot of shifts or a lot of hours to get something that's meaningful for creating your control chart. It must be in time series order. Now, control charts can be used for both continuous data and attribute data. Either one works. And keep in mind, I've got an example here I'm going to share with you. This one is actually a different type of thing. It's not a pure control chart. It's actually got upper spec and lower spec limits versus upper control and lower control, but you can change them easily. They're easy to calculate. So in this example, I've got an upper spec and a lower spec limit. So this is basically saying this is how I need to control this particular process of loading trucks. Now, if I did the upper and lower control limits, we'd be calculating those, as we said, the average plus 3 times the standard deviation and the average minus 3 times the standard deviation. But in this case, I've set a spec limit so I know how I'm doing within my truck loading capability. So there's many more data points that are on here. You can't see all of them. It goes down to, I believe, 30. But I just showed this for example. So in order to plot those lines, the upper spec limit or lower spec limit, or if you want to do the upper control limit or lower control limit, you just put that number in there once you've calculated it from the data. And then when you highlight the loading time and upper and lower spec limits, and then hit insert chart, it's going to give you this truck loading control chart. Pretty cool that you can do this very quickly in Excel. So again, these are great tools to use. This example is in your Ops University Lean Six Sigma Greenbelt Toolkit. If you want to learn more about creating control charts, more about time series plots, maybe run charts, individuals, moving ranges, there's a lot of different choices out there that you may want to seek. This is a great reference for you. The Lean Six Sigma Pocket Toolbook, along with Excel, you can do some amazing things related to tracking variation. That's it for variation, time series plots, run charts, and control charts. Thank you.